My name is Len Farmeyer. For those of you that don't know me, I am a Katahdin breeder, but I'm also the chairman of NSIP. And that's really the reason why I'm starting off the presentation this evening is I just want to say thanks to all of you all for everything you've done. I just want to give a quick little history and overview, and then we'll turn this over to Dr. Lewis, and he'll dig into the science and the analysis that he's been working on. But history-wise, excuse me, you know, this is the next year will be the 30th anniversary of NSIP forming as an organization. And we can thank a lot of people. I'm sure we'll talk about history a lot more next year, but Dr. Moracle at Iowa State was kind of the one that started the first program. And then anyway, Dr. Nodder at Virginia Tech ran it for quite a few years. And now you know, we've advanced so that we have sheep genetics in Australia helping us with the analysis. But the Fort Myers were the first Katahdins that submitted data back in 1993. Today, again, thanks to all of you all as volunteers, producers, NSIP has had its best year probably. We've hit some really big milestones, and I just, again, as chairman of the board, I just want to say thanks to all of you. There are over 100 KHSI members that are enrolled. The NSIP Katahdin database now contains over 90,000 records. So that's a significant amount of data. The last changes that were made in the genetic parameters, and actually that occurred in conjunction with the development by Dr. Nodder and one of his grad students of the hair index or hair maternal productivity or ewe productivity index, whatever we want to call it. That happened, you know, almost 20 years ago. And so it's been time for changes. Dr. Lewis has been telling the board that we needed to update things for a while, and we were, our focus was perhaps broken and finances were short, and it just hasn't happened. But about 5 years ago, thanks to grant writing ability of doctors Burke, Lewis, Morgan, Murdoch, and others, there was they won a very large USDA grant. And they recruited 23 different flocks to help them collect data over 3 years. And I'm not too sure exactly how many total lambs, maybe 7,000, but 5,000 of them had really good phenotypic data and genotypic data. And so that project, that grant basically has driven us now to the point where we are tonight. And the data collection ended in 2019, and then Dr. Lewis went to work on all the data. About a year ago, NSIP realized that this was something that, you know, genomics was coming. We needed to figure out, you know, what was going to work for producers. An ad hoc committee was formed. Tom Hodgman was part of that committee. Started meeting about a year ago in the fall and met every Friday at noon by conference call through the spring, early summer. And that basically, that ad hoc group was what kind of figured out what we needed to do so we all could submit tissue sampling units this year. And we didn't know how many you would submit. We were hoping for over 1,000. To date, we're over close to 2,000. So again, thank you for your willingness to participate in this effort to move forward. Dr. Lewis and one of his grad students traveled to Australia last January to work on this project. And unfortunately, because of COVID, they had to come home. but somehow through technology, Dr. Lewis and Dr. Brown from AGBU in Australia has continued this process. I think one of the important things to remember tonight as Dr. Lewis is presenting all this data, that as new data is collected, we need to keep updating our genetic heritabilities for the different traits and the correlations between those traits. We want to keep improving. And actually what Dr. Lewis is going to be, some of these changes we're talking about in the cattle industry, they're used to what we're going through now. They're used to having parameters changed on a regular basis. They're used to having new indexes formed or old indexes recalibrated. It's kind of become a non-event in the cattle industry. We haven't had this happen in 20 years or close to 20. And so I just want to stress tonight that this is a natural, what Dr. Lewis is talking about, these updates are a natural progression of animal science. We're just not used to it, but it's really something that's very normal. I want to stress that we've been using great technology, but basically Dr. Lewis over the last 18 months has updated that technology. We don't use ag phones anymore for cell phones. Most of us have smartphones. We want to keep updating that technology. NSIP is trying to do the same thing. The other thing I think I'm excited about from a point of view that this is something you can talk to your customers about. One of the analysis was a forward prediction analysis to basically double check this work that they're doing. So we can confidently tell our customers or the naysayers that, these EBVs have been analyzed with a forward prediction analysis. And, we've got, the results are very good. So all the updated genetic heritabilities and correlations have been reviewed by the NSIP Technical Committee. And then it was reviewed again by the NSIP Executive Board, and the Executive Board voted to accept the Technical Committee's recommendation that we go ahead and include all of these new heritabilities and correlations that Dr. Lewis will be talking about tonight. And we'll flip the switch on that and the genomically enhanced single step analysis on October the 1st. And so again, thank you for your patience in all this. There's one item that is not done yet, and that's the updating of the hair or the maternal index. And so here on this slide, I have highlighted in red these factors that are adjustment factors or whatever constants that are used in the formula. And these were developed almost 20 years ago when this index was developed, and they were accurate at the time based upon the parameters that were being used in the analysis. Because we're changing the parameters in the analysis, that means these factors need to be updated. And so basically the hair index as it's currently written will be incorrect after October the 1st when we make all the other changes. And so Dr. Lewis can talk about this tonight, but it really, his analysis shows that especially at the top end of the scale, it kind of shakes things up. And so we don't want to publish something that's scientifically unjustifiable. And so the executive committee has made a decision to not publish the hair index until it's recalibrated. And I use that term if recalibration because I just finished recalibrating the yield monitor in my combine. That's something I do multiple times a year. When we update the parameters on October the 1st for all the other traits, we will need to recalibrate, or we will need to reanalyze and come up with new factors for the hair index. So I don't want anyone to be excited or shocked. I don't want anyone to say, be concerned about this. Again, this is just kind of a natural process, and it's just the last step that we need to do, but it won't happen until late spring. And whoops. And so anyway, that's about all I need to say. I just want to again say thank you to everyone that's joining tonight. Thank you for your participation and support of NSIP. Thank you for your patience as we've gone through this process. And I'm just really excited about the things that are happening, and the increase in the accuracy, the increase in the predictive performance of the EBVs as we move forward. For those of you that don't know Dr. Lewis, he is, we're lucky in NSIP, we're lucky in the sheep industry that he is passionate about sheep genetics. As you can see here on the screen, his career has taken him across the United States and around the world studying quantitative sheep genetics. For those of you that have heard him before, perhaps at an expo or on a webinar, you know he's an excellent teacher. And some of the awards that he has received there at Nebraska, I think, illustrate that point greatly. So with that, I will stop sharing my screen. I'll introduce Dr. Ron Lewis and let him share his screen and have the rest of the evening. Thank you.
Many thanks for that, Lynn. That's a very kind introduction to me and to where we're going to be going this evening. Let me go ahead and share my screen. I'm going to leave my video off simply because our internet is only so dependable. So I'm hoping we'll keep the bandwidth to present without using the video as well. So let me kick this off. I'm hoping everyone can see a full screen. Is that true?
Yes.
Yep.
Great. So let's get right into it here. This is the outline of what I'd like to visit with everyone about this evening. I want to kick off with some of my perspective. I'm not sure we always do that enough. And I want to kind of tell you where I'm coming from and where I'm hoping to lead us to by the end of this evening's webinar. So I'm going to talk a little bit about ideas of change and just taking some time to think about what we're proposing. And then I want to give an illustration about accuracy. This is to set the foundation to the comments that I'll make related to the analysis we have done to move towards introducing these new aspects of our genetic evaluation. And I thought that foundation might help to set that scene. And then I'm going to spend a bit of time talking about what we've done, the analyses that Daniel Brown at AGBU and I particularly have been engaged in, re-estimating our parameter values. And I'm only going to talk about a couple of those to keep things in perspective. And then the consequences or benefits that we have seen with the incorporation of genomics. And then I want to finish up talking a little bit about where we're going to next with implementation of the changes that are forthcoming. So that's the plan for this evening. A little bit about my perspective, particularly on change. What we're proposing, what we're doing really does, hand on heart, reflect a positive, truly a positive evolution of the services that we're able to offer in NSIP. And the reason that evolution is happening is we have new technologies that we're incorporating into what we do to maintain a competitive and modern service to US sheep producers. And we have a lot more data than we did 20 years ago. In fact, in the past 3 or 4 years, we've increased the amount of data on Katahdins or on our hair sheep generally by about 1/3. And so we know a lot more. We have a lot more information and we have new technologies that we can take advantage of. But I want to keep it in perspective. that does not suggest that what we've been doing previously was in any sense incorrect. This is a natural process that Lynn nicely outlined. Change is important. Our evolution and what we do is important, but it does not by any sense discourage or deny all the good things that have happened up until now. And I think that perspective is really important as we embrace the changes that are forthcoming. The other thing is I want to take some time. I don't know about you all, but it seems that COVID-19 and the use of Zoom and these technologies has made everything feel really rushed. And I must say I'm getting tired of feeling rushed all the time. And so I want to make sure that we take enough time in tonight's webinar that you feel comfortable with what's forthcoming, because you're going to be the ones who will be receiving the new results. You'll be utilizing that information, you'll be explaining it to your clients and your customers. And so it's really important to me that this evening is all about explaining and understanding the changes that are forthcoming. As a consequence, I see it as a conversation. So please do type in questions into the chat box. I'll stop every once in a while when I think it's timely to do so to try to address questions, because that's what tonight is all about. It's a conversation to make everyone feel comfortable with what is forthcoming. So those are my perspectives that kind of kick us off. So I want to begin by giving a bit of a foundation about accuracy, because what we have done in looking at our new parameter values and in incorporating genomics impacts the accuracy of our genetic evaluation. And accuracy in its simplest form is simply the correlation or the relationship between an animal's breeding value and the information we use to predict it. The higher that correlation, the stronger the relationship, the better the prediction. And so accuracy really encompasses how much confidence we have in our estimate of an animal's merit based on the information that we have in order to predict its breeding value, its estimate of its breeding value. Now, in the simplest case, where we base our prediction of an animal's breeding value only on its own record, ignoring everything else from relatives, progeny, parents, what have you, the accuracy of an animal's estimated breeding value is the square root of the heritability. And H squared is the symbol that we use for heritability. Heritability is going to vary from 0 to 1. And so as that heritability goes up, its square root goes up, and the accuracy of our prediction of an animal's breeding value goes up. And it's really just that simple. And that equally impacts our estimate of the breeding value. As the accuracy goes up, tells us we know more about the animal's true breeding value. We're able to estimate it more accurately, and that's reflected in its breeding value. So let's take a look at what that means in the context of the kind of traits that we work with in all of our breeds, in hair sheep, particularly in tonight's discourse. So here's an example. So what I've done is I have the heritabilities along this first column. They go from 0.05 up to 0.5. We tend to classify these in brackets because it's easier to think about them as categories rather than individual values, because within a category, they behave pretty similar in their consequence, or pretty similarly in their consequence. So heritabilities that are between 0 and 0.2 fit in the low category, between 0.2 and 0.4 are moderate, and those above 0.4 we typically classify as being highly heritable. And what we see if we take the square root of those heritabilities and we look at the accuracy, if all we know about an animal is its own performance records, these are the accuracies that we would have. So for our lowly heritable traits, The accuracies are unsurprisingly relatively low. As we go to the highly heritable trait, the accuracies become higher. And what's an important context about genomics, if I might say, is where they're going to help us the most. And I think you're going to see that as we talk about some of our results later. Their biggest benefit is in these lowly heritable traits. Simply an animal's own performance record, if something is highly heritable, is a pretty darn good indicator of its breeding value. It's really when those heritabilities are low where our genomics are going to help us the most. So clearly, heritability goes up, so does the accuracy, and we must be aware of vice versa. So if the heritability goes down for a trait based on new information that we have, the accuracy of its evaluation is also going to go down. So keep that in mind as we talk about the results from our analyses. But I want to give you a bit of a context of what genomics does for us. Okay, saying, and there's no genomics in this example at all, but this is what genomics does. It provides us more information that we can use to estimate an animal's breeding value. So let's imagine that we have enough genomics that it is comparable to having information not only on the animal itself, but on 5 of its paternal half-sibs. So these would be the accuracies that we would see with that small amount of additional information. They all go up, but they go up proportionally more when we have these more lowly heritable traits. So more information, in this case, our 5 paternal half-sibs, the more accurate our evaluation. Now with genomics, we're kind of getting more into the category where we're mimicking something in the range of 20 paternal half-sibs if we have nicely structured data. So what we then see is a greater benefit because we know more. We have more information on which to estimate an animal's breeding value. The accuracy of that estimate goes up, and we see that reflected in these accuracies. Notice for the highly heritable trait, the accuracy change is pretty trivial. For our lowly heritable trait, it's not quite doubled, but it certainly has gone up pretty appreciably as we get that additional information on this animal. And in my example, 20 paternal half-sibs, trying to mimic what we will ultimately see as we add in genomic information. Okay. And again, emphasizing the benefit is most or greatest when heritabilities are lower. So Rusty, I'm going to stop there for a moment. Are there any questions for anybody or from anybody, anything in the chat? Because this is going to be the foundation of some of the ideas that we have as we go forward.
I don't see any in the chat, Ron. Does anyone have any questions before we move forward?
Rusty, anything needed to be added to clarify that?
I think you're hitting it on the head so far, Ron.
Okay. All right. Don't hesitate to ask questions. Again, this is a conversation, even though I seem to be talking to a computer screen here this evening, which seems to be the nature of Zoom these days. All right. I want to explain what we've done. And it has taken a fair bit of time to do this because we wanted to make sure we got it right. So we have run and rerun and validated these analyses innumerable times. So hand on heart, the science is sound. So what you'll be receiving when this switch is thrown will be a truly well-validated improvement to how we go about our genetic evaluation. So one of the things that we did is we re-estimated the parameter values, which means we have new values for heritabilities and new values for correlations among the traits that we evaluate. Our genetic evaluation is based on what is called a multi-trait evaluation. So we learn something about a trait based on other traits that are recorded that are correlated with it. So when we re-estimate parameters, we have to look at all of our traits together, look at how heritable they are, and look at how they are correlated with one another. So we've done that using our full data on Hersheet. And then what we also did is we threw on top of that the information we have gained through genomic evaluation. And as Lynn mentioned, those have come from a grant that Dr. Joan Burke has led, where largely because of economies of increasing costs of doing genotyping, we're able to actually collect genotypes on 5,000 animals, when originally we only thought we had the funds to genotype about 1,250. And that change has been tremendous in allowing us to do where we've gotten to today. So that's what we've done. We've re-estimated all of our parameters, and we've incorporated in genomics, and we've looked at the consequences of those changes. And this is what we've done as part of our testing. We wanted to look incrementally at each change as it was introduced. So there's 4 variations that we're going to talk a little bit about tonight. So the first one is what we currently are doing. Our current parameter values, ignoring the genomic information entirely. And I'm going to refer to that from here on out as our current scenario, or our current variation. Number 2 on the list, what we did is we used our current parameters, no change there, but we added in what we learned from genomics, and I'm going to refer to that as genomic. So that's genomic information being added to our current set of parameters. Third variation that we've looked at was to update the parameters, but to ignore the genomics. So this is only the change in parameter values, and I'm referring to that as param. And then lastly, updating both the parameter values and adding in the genomics. And that is what I'm calling our plan. So to be clear on what you'll be seeing as we go forward, when we look at these changes, we're going to be moving from current, that's what you're getting today, to plan as we move forward in late September, early October. But I think it's important for you to see some of these interim steps to understand what these changes really mean. Okay? So I'm going to illustrate these changes with 2 traits because I think they're nice examples of what we see. They're kind of boundaries on the kind of changes that have come about from these updates. The first one is post-weaning weight, which is measured in kilos. And to give you a sense of what happened when we re-estimated the heritabilities, it reduced a little bit for this trait. Its heritability before was on the border of moderate and low. It's now slightly low. So there was a small change, a few percentages, as when we re-estimated the heritability for post-weaning weight. And the second trait is post-weaning fecal egg count. It's measured as a percentage, as you all well know. Turns out that had a substantial change. The heritability for post-weaning weight halved. It went from being highly heritable to moderately heritable. Let me re-emphasize one of my perspectives. That doesn't say that we were wrong or it was wrong when it was thought to be highly heritable. At the time that work was done, where that estimate came about, there was relatively limited data on fecal egg counts in a few flocks, and the estimate reflected that state of affairs. Now we have a lot more information on fecal egg count, and it turns out that the heritability is lower than it was originally thought to be. Okay, so those are going to be our 2 traits. So let me give you a heads up. There's a lot of data in the background of all of these slides. So sometimes there may be a little bit of hesitancy before it appears, but it'll show up in due course. I wanted to provide a benchmark for what you can expect to see through these slides. Okay, so this is a graph. It has current along the along the horizontal axis. So this reflects what we're currently doing. The vertical or y-axis is going to reflect a change as we move through these 4 variations. What the black line represents is a one-to-one correspondence. So the black line means, or anything that lies along the black line, means no change, in this case in an estimated breeding value, when we move from a current to whatever variation we happen to be talking about. That's a pretty key point. So let me stop again, Rusty, to make sure everyone is kind of happy with where we are and where we're going to go before I start throwing up some of the results. Anything out there, Rusty?
I don't see anything in the chat just yet, Ron. Any questions before Ron moves on? I think we're safe to proceed.
Okay, then hearing none. Thanks, Rusty. I'll continue. So this is the first variation. Again, as a reminder, all we have done, used our current parameters, but we added in genomics on these animals, and or genomic information, and there are about 5,000 animals with genomics. The data that you're seeing are animals born between 2016 and 2020. There are about 33,000 animals being represented ultimately in these graphs. What you see is in the red, in those red circles, those represent those animals that had a genotype. So they had genomic information. And what we see is they pretty much lie along the line, but we see those breeding values going up a little bit on average. And part of the reason for that is the genomics is giving us a bit more information on which we can use to estimate breeding values. But overall, we're not seeing a huge change. They're kind of lining up as they had always done. When we add in the animals who do not have genomics, we don't see any of that bolster. They're lining right up where they historically would. Some above, some below as they ought, but basically they line up pretty closely to where they were before. Okay, so that's the scenario if all we do is add in genomics. So let's now add in the change in parameters. No genomics, just the update in the parameter values. As a reminder, the heritability reduced a little bit. It went from sort of the lower moderate to the upper low in our classification of heritabilities. And notice with that change of parameters only, things came down a little bit. Okay, again, these red circles are those animals only with, or those animals that had the genomic information on them. So we see a bit of a constraining or drawing in, if I may, of the breeding values. Very much what we would anticipate. When we add in the animals who do not have genomics, see a very, very similar scenario. Things falling back a little bit, but they're pretty much lining up as they always have. But this is the consequence of that change, that slight reduction in heritability. There is no genomics here. So this has nothing to do with our adding in genomic information. So what happens if we do both? This is what we see. This is our plan. So here is the new parameters and the genomics. We sort of regain what we had with the genomic information because we're adding that in, even with that slight reduction in the heritability of post-weaning weight. And when we add in everybody else who do not have genomic information, they also show some benefit. They jump back to where they originally were because they're related by pedigree to those animals that have genomic information. So they benefit from those data. So that's our story with post-weaning weight. Slight reduction in heritability. There's a consequence of that, but we spread our breeding values back out. once we add back in that genomic information. Okay. So let's now move on to accuracies. Okay. So I'm going to have the same set of 3 pictures, but now what we have are the accuracies on the two axes. So accuracies go, it jumped, sorry. It has a mind of its own. Anyhow, they go from 0 to 100, 0 to 100. My dear PowerPoint seems to keep wanting to knock it back to -20 no matter what I do. But notice that we have these higher accuracies associated with our genomic, those animals with genomic information. And we also tend to see the greater benefit for those animals that are in the moderate accuracy category. That's what we tend to see. Genomics are helping animals most on which we have less information. If we add in the animals that do not have a genotype, what we end up seeing is they pretty much lie along that same line, but we still see a benefit or a greater benefit in those animals with the more moderate accuracies as we go into their evaluation. If we now jump to what happens if we only change the parameter, there's no genomics. Again, from our earlier discussion of the consequences of a reduction in the heritability, we lose some accuracy. And that's what we see. You can barely see the red marks along the top here. So we don't lose as much accuracy as for those animals with the genomic information, but it does tend to come down a little bit when we have the parameters. And let me be careful. I'm not trying to imply the genomic information is having an impact in here, but those are the animals that we probably knew a little bit more about full stop based on the fact that they were fully recorded as part of the evaluation. But what we're seeing is a reduction in the accuracy overall because the parameter, the heritability, was reduced for post-weaning weight. If we move to where we're going to end up, adding in the genomics on top of the change in parameters, basically we get back to where we started from. So we see this benefit, particularly for those animals with genotypes, but they are also affecting the entire evaluation, and we return to accuracies very similar, a little bit better than what we had before we made these changes. Rusty, I'm going to stop there again, because that's what I want to say about post-weaning weight. Any questions about that?
I have a question for you, Ron, on your graph on the left, where you depict the changes due to incorporating the genomic information. You said that there are animals that were not genotyped, yet they still showed a slight increase in accuracy for those animals that were on towards the left of that graph. Could you just kind of briefly revisit why that is? Even though they're not genotyped, why are they getting a benefit from the genomic information?
The reason is because we're just able to do a better job of evaluating those animals that have genotypes. And because the other animals without genotypes are related to them through their pedigree, when we do a better job of evaluating those with genotypes, that trickles through the whole evaluation. And so we see a benefit. And that's one of the beauties of this technology, is that it has a broad impact across the entire evaluation. That does not mean, let me emphasize, that we can stop recording animals, because the only way we're seeing this benefit is because we're getting records on those animals with genotypes. We're getting records on those animals without genotypes, and they're being related based on their pedigree, the fact that they're related. And so bottom line, because we know more, we're able to more accurately evaluate all of the animals in our evaluation. Does that answer, Rusty?
Yes, but just because we're seeing that benefit, we still need to continue recording our animals, and we'll need to continue genotyping some animals as well, correct? We can't just genotype them this one batch and be done with it. Is that right?
Absolutely. There's a lot of evidence out there that when you get very far away from those animals that have genotypes and performance data, the benefit of the genotypes that you collected historically fall off in a hurry. So this is going to be an ongoing need for our industry to be genotyping a proportion of our animals every single year to keep those animals with genotypes current, reflecting our current animals that we're making selection decisions about. So although it would be nice if it was otherwise, this is the beginning of a continuum. It will not end. Anything else to clarify, Rusty?
Well, I think it's very interesting that there's animals with a lot of information where we already have high accuracies. We're not receiving a great benefit, but in some of those younger animals or where we have our lower accuracies, we're seeing a tremendous boost in those animals in the accuracy of their evaluation. So I think that's very neat. Do we have any other questions for Dr. Lewis before we proceed?
This is very much what we expect to see. Just to clarify, down here at the right-hand side, these would tend to be animals that may not be well recorded, and they're not particularly well related to those that are. And so when you have that disconnection, they're not benefiting from the information being generated from those animals with genomics and who are related to one another. And this goes back to some of the discussions we've had historically about genetic connectedness, equally relevant here as it has ever been. All right, so now I'm going to move on to our alternative trait, which is post-weaning fecal egg counts, EBVs, and those again are represented as percentages. Basically, the lowest breeding value is around a -100. That's a good thing. Lower values are better, as you all know, and higher values would imply that an animal is more susceptible to gastrointestinal nematodes. But that's what it looks like if we add in genomics alone. See a slight benefit, but things pretty much lie along the line that they always do, and very much what we anticipate. Tendency to get a little bit more benefit down here at this end, but still things are behaving as we would anticipate. This is the big factor that, oh, sorry, forgot to, my next picture there, I'll stop for a moment. For those animals without genomic information, they're pretty much lying along the line as well, as we would anticipate. They're getting some benefit from being related to those animals with genomics, but basically the EBVs are pretty much lying right along that same line. Okay. So the next picture is the one where we see the greatest consequence in all of the evaluations we're doing. Remember, the heritability that we are going to be implementing in the upcoming month for post-weaning fecal egg count was reduced by half. It moved from being high to moderate. The consequence of that is substantial. And we see that on these breeding values. They're being compressed, they're being pulled back. And the reason for that is rather than being able to say that half of what we see in the way these animals perform, their actual post-weaning fecal egg counts, is due to the genes they're inheriting from their parents. Instead, it's only a quarter of what we see that we can assign to their genetic background. And that has a tremendous impact on breeding values. It draws them back. And that's what we're seeing both in the, when we have the animals, well, sorry, for animals, when the only change we're making is in the parameter values. And we're seeing that consequence both in those with genotypes and those are not. And again, reminding you here, no genomic information is being used in this case. What we've done is halved the heritability of post-weaning fecal egg count. So there's a large consequence of that change. So what happens when we do add the genomics back in? In anticipation, I'm hoping it's going to be a moment. Here we go. So this is where we're moving to. Notice that there is an improvement. There's a gain, if I may. The EBVs that we're seeing when we look at the current versus what they're planned, they're getting a little bit closer back to that black line. It's not compensating for the entire consequence of that change in the heritability, but we do see that benefit of genomics coming in, given the fact that we now know more about these animals because of that genomic information. Okay, Rusty, I'm going to talk about the accuracies as well, but maybe that's a good spot to stop, because this is a pretty important result that we have seen as a consequence of some of the changes that we will be implementing. Any questions or comments, Rusty?
I don't see any questions in the chat. Do we have any questions for Ron?
I have one. This is Roxanne. When it comes to post-weaning fecal egg counts, do you take under consideration that some are being collected at when a lamb is 80 to 90 days old, as opposed to some that don't get enough of a challenge until they're 120 or 240 days old? Because, you know, nutrition plays a big part.
It's a great question. Currently in this evaluation, we don't have a good way to discern the level of challenge, the level of infection that these animals have faced. I have a graduate student that I'm working with at the moment, and our focus is going to be very much just on that point. I would like us to do a better job of accounting for, trying to account for, whether an animal has low fecal egg counts because they weren't challenged, or low fecal egg counts because they were challenged and they were resistant to it. And I think we have some new tools that will allow us to do that better. But in the current evaluation, that's not being handled as well as I would like. And I have to say, it's not being handled well anywhere in the world at the moment. I think we can do better. And that's one of the evolutions I think we want to pursue.
Ron, this is Jim. So are you going to show a slide? The animals don't really re-rank. They're just getting a change in their EBV for the most part.
What we're seeing is kind of a drawing back. I've not said anything about ranking. It's a very good point, Jim. I'll show something about ranking a little bit later.
Good enough.
So what we're seeing is these are drawing back because the heritability is less. And so an animal that had a higher fecal egg count EBV now will have a smaller fecal egg count EBV. And that's happening at both ends. So things are being drawn in towards the middle. And I'll show some slides with accuracies, and then I'll show something on ranking to hopefully make that point even clearer. But it's a very good question.
Ron, there's a similar question in the chat, and I think part of it is the scale on the graphs. It's a little bit hard to delineate. Is it right that the better values, as in the large negative estimated breeding values, are they being impacted less due to these changes than say on the other end of the spectrum, or is it a fairly even change across the board?
Well, I mean, it's a very fair question. I think it's very proportional. I mean, for an animal to get a very negative, a very good estimated breeding value, typically we need to know a lot about it. And so given that's the case, even with this reduction in the heritability, the consequence will become less than when we have animals that we know less about. And so my expectation is, and I can't quantify that off the top of my head, is that the impact is less at this, excuse me, at this negative end than it will be at the more positive end.
And I think, well, some of that will probably be explained when you move on to discussing the accuracies, because isn't that one of the reasons why accuracy is built into the EBV itself, is that it requires substantial information to make it to the two extremes?
Exactly. An estimated breeding value has accuracy as part of its estimate. And so it's there. And there's always a debate on whether or not accuracies help or confuse, because we're already dealing with accuracies when we actually estimate an animal's breeding value. So let me go on to that. Excuse me. So these are now the accuracies for the fecal egg count EBVs. Again, red circles there are the animals that have genomic information, and we certainly see that benefit. So again, we see the greatest change for those animals that have the lower to moderate accuracies. Very much what we would anticipate seeing. So if we then move on to adding in all the animals, those without genotypes, those are again, these green, we see this greater spectrum, but that probably even accents more the benefit to those animals with genomic information. What happens if we change the parameter values? Well, the accuracies do fall. You know, they tend to be less than that black benchmark line, and this is reflecting that reduction in the accuracy, or the reduction in the heritability that's impacting the accuracies. So there's no genomics here, just that halving of the heritability for fecal egg count. Okay. And the final part of that story is if we add in the genomic information on top of the changes in parameters, basically we begin to regain some of the information that we had otherwise had lost in reducing those heritabilities. So you see the accuracies on average going up, but we still see a small decrease in the accuracies overall. The animals that are benefiting the most are those that have the genomic information. I'll stop there again, Rusty.
Any additional questions for Ron?
Okay. Point to be made, as we collect more data and more genotypes, the benefits are going to grow, which I think is a really exciting prospect. All right, let me move on to a different way to think about this that I'm hoping is comfortable for you. What this slide shows are percentile rankings, okay? And what I've done is I've pulled out the animals born in the last couple of years that are perhaps still higher on the list in terms of those we're most interested in utilizing. Only those animals that had a post-weaning weight are included in this picture. And the reason is I wanted to make the comparisons fair. I didn't want to be comparing those with and without their own data as we moved across our different scenarios. And there were about 8,500 animals with post-weaning weights born in 2019 to 2020. And there would be several thousands of these animals that would have genomics, okay? So this is what our current cutoff points would be as we move down the percentile range. So 9.9 kilos would be the cutoff for animals in the top 1%. If we drop down to 90, 4.45 would be the cutoff for those in the top 10%, and so forth and so on. Okay. When we add in the genomics, we're not really seeing a huge change in that spread. There's some slight changes in the cutoff values. They're going up a little bit. You saw that in some of the slides that I showed before, but the spread is relatively similar to what we have seen with just the current evaluation. So here, if you're picking in the top 90%, the cutoff would be 4.76. If you're picking from the top half, it'd be 2.26 rather than 2.04. So what's the consequence of the parameter change alone? Well, we draw everything back in, as we saw in some of those pictures. So the maximum value and the minimum value come back a wee bit with that reduction in heritability. And with that, so do the cutoffs. So the top 100% is now at about 8 kilos rather than at near 10 kilos. The top 90, the top 10% would be 4.2 kilos and above versus 4.5 or 4.8. And when we get to the top half, it drops down to about 2, a little bit under 2, 1.9 versus 2 or higher, or with the genomics alone, the 2.23. Very much what we expect, kind of a drawing back in. When we add the two together, parameter changes and the genomics, what we see is things spread out a little bit again, as we anticipate, and the cutoff points actually then go back up. So we're here at the top 10% would be 4.43, very similar to what you currently would have seen. The negative end is drawn back in a little bit, but if you're picking in the top half for grins, it'd be 2.1, very similar to the current. So this is what we're seeing in terms of the actual impact on rankings. And if we take a look at a similar scenario with the fecal egg count, this is what we see, a very same set of concepts, right? Current top 10%, the cutoff would be minus 97. Top half would be minus 58 or lower. With the genomics, not a huge change. Top 10 would be very similar in their cutoff point. Top 50, very similar as well. The range is a little bit broader, but not substantial. We always need to be careful of those here at the 0, because that can be an animal that's a little bit unusual. But look what happens when our only change is the parameters. Everything gets drawn back in, as we saw in some of those pictures. And as a consequence, the top, the top 10% would go from being the cutoff of minus 97 to minus 86, and the top half, a minus 41 versus a minus, say, about 60%. Okay. When we add the two in together, we don't see a huge change. We still are facing the consequence of this halving of the heritability for post-weaning fecal egg count. So we see very similar cutoffs as we saw with just the change in parameter values. We still have this drawing back in, if I may, of the breeding values as a consequence of that set of changes. In this case, again, 2019-20 animals, only those with post-weaning fecal egg counts, and there were about 4,000 of them that fit that category. I'm going to stop there. Again, Rusty, those are all the data that I plan to present.
Can I ask another question? Hypothetically, if you had 2 rams that were both minus 100, but one had, say, 150 progeny and the other one 20 progeny, would the one with the higher progeny go down the same rate as the other one if they started out the same?
My guess, and again, it's just based on what we're talking about, the one that has a lot more information should change less.
Okay, that's what I thought. Thank you.
And the reason about it is it's just all about information. All genomics is a bit more knowledge about an animal. You know, it's not the same as adding additional progeny or additional records, but it's conceptually the same idea. We're just learning more about the animal's true genetic merit. Anything else, Rusty?
So a lamb with only his own data will be a lot less than he would be less impacted by this, or more impacted by these changes than when. Go ahead.
Yes, the less we know about an animal, my view is they're going to be more impacted by some of these changes. As animals are accurately evaluated, they tend to be less susceptible to some of these changes. As they're more related to other animals with data, they tend to be less susceptible. But for an animal that we know very little about, we're estimating its breeding value basically on its own performance at best. And you saw the consequences of that on accuracies, and that's going to be reflected in the breeding value estimate. Anything else, Rusty?
Any other questions for Ron?
Okay, so the impact of these changes really fit what we expected, given what they were. You know, if we think if the heritability is unchanged, that meant the parameters didn't really have a huge impact when they were re-estimated. Breeding values don't change much. The accuracies don't change much. However, when we add in genomics, we spread those breeding values around a little bit more, and we increase the accuracies, very much what we anticipate. If instead there was a decrease in the heritability, the best example was our post-weaning fecal egg count. With that change in that parameter value, we saw that contraction, that drawing in of the breeding values, not necessarily re-ranking, a drawing back in, and we see a decrease in the accuracy of that estimate. When we add the genomics in, they get spread out again a little bit, and we increase the accuracy because of that genomic information. So a couple key conclusions. The changes that we're seeing, the contraction in breeding value estimates and the reduction in the accuracy is only because of the changes in the parameter values. It has nothing to do with the genomics. We need to keep that very separate. And as Lynn said, it's been 20 years since those parameters have been reevaluated. We need to think about how routinely that's done so that we don't see quite the change that we're experiencing with this. But nothing to do with the genomics. It's only due to the parameters. And really the incorporation of the genomic information is improving matters. We're getting that increase in the accuracy of evaluation, not only on the animals with genomic information, but on those who are related to them. So it's a win-win, if I may. So we need to make sure as we're reaching out to others as to what this all means, this is how the change is coming about, and it really does fit what we'd anticipate given changes in parameters and the incorporation of genomics. So going forward, Lynn already had mentioned that the NSIP Executive Committee approved these changes being implemented. They will coincide with the September 30th data submission. And Daniel Brown and I have been testing to make sure everything is ready to run. There are about 1,000 more genotypes that'll be coming on board above those that I was showing you tonight. So that will make matters better. So I'm tickled to see that we've had another huge explosion in the number of genotypes that are going to be incorporated. We're providing outreach to breeders, these webinars. There's the one tonight. We'll hold another one on September 30th. So if you have questions in the interim, please come back and revisit with us at that point in time. We want people to be familiar with the changes that are going to be coming about. And then I believe Rusty has the intent of some follow-up webinars once you actually see your new results so we can talk them through. Lynn already mentioned the US hair sheep index. The changes in the parameter values do affect its construction. We have a plan in place to amend that index accordingly. We're going to get that done with a spring time schedule. And so the plan is to relaunch that index in spring when people are beginning to take their next set of decisions. But our wish is to defer reporting in the meantime, just to make sure that we're fully transparent and accurate in what we present as being part of the NSIP. So that's going forward. Okay. Any questions on that? I only have one more slide.
Ron, I just real quick, I wanted to reiterate that the current index is an accurate representation of that index. It's current with the current parameter values. It requires updating once we update the input parameters, the things that you presented here tonight. So it's not like all of the old data is not correct. Those are still useful index values, but once that switch is made, that's when they become a bit outdated.
Exactly. Again, in my perspectives, and I'll make a conclusion along that line, what we've been doing up to now has been with the best knowledge that we had, and it was helping us move forward. And it certainly has, if you look at the genetic trends in hair sheep. What we're planning is better. And so we need to be very careful of casting out the old with the sense that somehow it was not correct. What we're able to do now with these changes is to make improvements, which is what we always wish to do. And as a consequence, it will affect the index. So we need to get that index right. And so we plan to have that in play for springtime. So I actually have two more slides.
Okay.
Oh, yep.
Plus, I do have a few more questions in the chat. I do see those.
Oh, okay.
One of them I'll address right now. It's several folks have asked, these changes will be made on the October 1 data run. They've asked, do they need to submit data in order to receive updated results? Lynn and I met with the folks at WAM Plan last week, and we should have it worked out that anyone who has submitted data in 2020 or 2021 lamb crops, you should automatically receive a set of updated reports. So you shouldn't need to submit data to receive those. They should automatically come to your inbox. So if you've actively participated in the last two lambing seasons, you should receive those. One little quick follow up on that is, I mentioned in the note that I'd sent out to everyone that, and Ron just mentioned, that we'll have a follow-up discussion just like this after those results come back. That please keep that date a little bit fluid, depending on when we actually get those results back in hand. We might need to change that date one way or another, just mainly so Ron has a little bit of time to look over what the changes might have been that occurred, so we can accurately answer any questions that come up. So we'll try to stick to that date that we had announced, but try to plan on that being just a little bit fluid.
So Rusty, just to clarify, that the date that I put up would be for the webinar before the release. Is that correct? Yep.
Yes.
So the September 30th, I think we'll go ahead with. It's the ones thereafter you're referring to.
That's correct.
Straight?
That's correct.
Okay.
Yeah. So just real quick, I'll get to a couple of other questions that came in the chat box. There was a question about, and I know you're deeply tied to the beef industry. Could you maybe just allude to maybe what some of the benefits that the cattle industry has seen due to genomics, and are these falling in line with about what you would expect in your previous experience?
Very much so. It varies. The benefit, as I hinted at, varies depending on the heritability of the trait. A little more lowly heritable, the greater the benefit, but the percentage increases if we only looked at the change in genomics. Again, we're doing both together here because it seems sensible to do it all at once. But if we only looked at the change in genomics, or adding the genomics, very much in line with what we see in beef. which is very exciting and although not surprising. So basically, we're benefiting from the same technologies that they've had in place now for quite a few years.
And I think it's important to note that we've also been able to learn from some of their pitfalls. And as you've been working to develop this, we've been able to avoid some of those right from the get-go.
What we've learned a lot. So one of the important things, and I give credit to the project that Dr. Burke led, is when we set up those 5,000 animals that we had genotypes on, we did a really good job in representing all of the kinds of lambs that were available at the time and their sires. And that's been a huge advantage to our developing these technologies. Some of the hiccups that happened historically is there were very small subsets of animals that were genotyped that tended to be at the upper end. That doesn't do nearly as good of a job at giving our foundation. So within the Katahdin, we have a really nice benchmark foundation, a reference population, as you've heard me call it, to build upon. And so I'm tickled with how we can grow from there. And that is not something that was originally done well in some of our other livestock species. So yes, I tease my beef colleagues. I'm glad they messed it up. I learned from them. We got it right the first time around.
Good deal. I think we have one more question at least, and I'll let you move on. You touched on this just a little bit, but given that there's differences in the number of progeny in the data sets with our parents, some with very few progeny, some with several hundred. You mentioned that less accuracy means more change expected. Should we expect more change in percentile rankings for animals with lower accuracies?
The answer to that is yes, more change. And that change may be up or may be down. One of the underlying principles of what we use, which is called best linear unbiased prediction. The term unbiased means that our estimate is no more likely to go up as it is to go down as we get more information about an animal. That's what unbiasedness means. However, if we have animals that we know very little about, and it turns out the new information says they're much better than we thought they were originally, or contrarily much worse, we're going to see a larger change in their breeding value. If we have animals that have hundreds of progeny on the ground, we do a pretty good job of evaluating them no matter what else we do. The genomics doesn't help very much. We just know a lot about them because they have a lot of information. Those animals, we tend to see much smaller changes in estimated breeding values, either up or down. I hope that answers it, Rusty.
I think so. And I think that hits most of the questions we have. So we can get to your last couple slides and then revisit.
Okay. Some of you may know, I hope most of you know, that we put in a proposal to the USDA NIFA funding opportunity. And that proposal was called Improving Robustness and Climatic Resilience in US Sheep Populations Through Genomics. And I'm tickled for the level of support that we received from many of you through Katahdin Hair Sheep International and the Eastern Alliance for Production Katahdins and from Katahdin producers in general. And I am tickled to be able to say that we learned yesterday that we were successful.
That's awesome.
Woohoo! Woohoo!
So our grant was very well rated. And I have a conversation at the end of the week with the program officer at NIFA to talk about some of the fine tuning, but all the mechanics going well, we were going to be able to kick off on the 1st of January of the upcoming year. This is a tremendous opportunity for us. We're going to be able to look at a lot more interesting traits within our hair sheep breeds, but we're going to be able to do exactly the same in a variety, in all of our breed groups. We're going to be able to begin to establish genomic reference population across all of our NSIP populations. And we're going to be able to do it in a very robust way. So again, I'm extremely grateful to all of you who have been supportive of this. There is no question that your letters and your willingness to step up to the plate made all the difference in what we were able to do. One of the comments of a referee was that the effort that went into and the degree of support that we received from the sheep industry was a sign of how important this proposal was, and they thought of that very highly. So thank you very much. Would not have happened without you. So watch this space. We'll be moving forward here in a hurry to get ourselves revved up for the start of the new calendar year. And so with that very promising, exciting news, I just want to return to my original perspectives. And those relate to change. What we're doing reflects a positive evolution of the services we offer in NSIP. We will be offering with these updates the most modern genetic evaluation that's available to any livestock species out there. And I'm really tickled we've moved to being able to do that. It's based on new technology. It's based on having more information, more data. And I find this very, very exciting. Some of the changes are going to take a little time to get accustomed to, but in my view, this is all very positive, and it's a reflection of where we in NSIP need to go. And I'm excited to be part of it, and I'm hoping you're feeling the same. And with that, I am happy to entertain any other questions, Rusty, that may be forthcoming.
Well, very good, Ron. First of all, a huge good on you to you and your entire team for putting that proposal together. So congratulations on that. Please, if anyone has any questions, feel free to use the chat box or chime in. I just wanted to reiterate a couple things really quick. I want to reiterate, it's not that what we've been doing this whole time was wrong or flawed. We're just building upon that and making improvements. We're very much standing on the shoulders of giants who put together an awesome framework for us to build upon. And we're just making improvements upon that. And it's as much work as Ron has put into this. It's not just Ron standing up there on those giants' shoulders. He's got a top-notch team there that's helping him out. He's got a great technical committee at several of our land-grant universities and our USDA ARS facilities. Dr. Daniel Brown and his team have been huge helps in all of this. Please remember, I think pretty much all of this work was not written into that original grant proposal. This has been possible because we have dedicated people that are passionate about making our evaluation the best that it can be so that you all can make our industry successful. So very much appreciate you doing all this work, Ron. And please, if you have questions, let Dr. Lewis know. And I'm going to mute my microphone real quick because there's a car in the hotel parking lot going off. So.
So I fear I've stunned everyone into silence here. Please, again, this is a conversation to help understand what these changes mean. So please do ask.
There are a couple of questions in the chat window, Rusty.
Yep, I'm seeing those here. So I didn't want to bore you all with the horn going off in the parking lot here. One of the first ones I see here, Ron, is there's several producers that have limited years in NSIP. They're working on building genetic connections, working on building their databases and accuracies. How do you see implementing these updated parameters and genomics affecting those flocks, their accuracies and their estimated breeding values?
Well, the benefit, let me back up and let me give a bit of a starting point to that. if those flocks are connecting to other flocks that are in NSIP, particularly other flocks that have a longer history, and the flocks that have embraced genomics, they're going to benefit from that. So the accuracies of the evaluations of their animals will improve as a consequence of those associations. And so my recommendation would be to continue to collect data, to be very strategic in the RAMs that they use to make sure they're benefiting from what's happening in other flocks, and continue to record. And in due course, they're going to start seeing the benefits of that effort in terms of greater accuracy, greater confidence in the breeding values they obtain on their animals.
Any other questions I see here? I'm going to have to defer. Is there another TSU batch date set? And I apologize, I'm not in the office. I'm in Miles City, Montana right now. Lynn or Tom, do you happen to know what that date? We had set a fourth date. I don't remember what it was because I don't have my materials. Do you happen to know?
I was thinking it was in December, but I'm not positive.
I mean, we can always set another date if there's enough interest. If there's enough people that would want to send in samples, we can set that date up. So if you have samples to send or you'd like to collect some, let one of us know. Let me, let Tom, or Lynn know, and we can announce a new date. So another question here is, will the oh, go ahead, Tom.
I was just going to say that technically what we need is 100 samples minimum from a variety of, from one flock or from a variety of flocks. If you put out a call for that sometime in later in the fall, I bet we get 300 samples, but that's just a guess.
Yeah. Okay. Another question is, will the searchable database indicate whether an estimated breeding value is based on DNA? First, Ron, could you answer a part of that? Is you mentioned that some animals are genotyped and others are not. Does that mean that only those genotyped animals have genome enhanced estimated breeding values?
Once we throw this toggle in early October, it is all evaluated one and the same. And so there's no distinguishing in a sense between those animals that do and do not have a genotype in terms of what you will see in your breeding value. They're going to benefit from the fact that they'll have relatives that have genotypes, even if they do not themselves. And so I think there's been some discussion of indicating whether an animal has a genotype itself. And Rusty, you may be able to fill in there for me. But every animal in the evaluation is going to be benefiting from the work that's being done to collect data, to record pedigrees, and to include the genomics. It's not as if there are genomic enhanced EBVs that are separate from our traditional breeding values. They all meld together.
Yeah, so all of the EBVs will be genome enhanced EBVs, but we will have an indication in the searchable database to indicate whether a sheep has been genotyped or not. I can't tell you an exact date when that will go into effect because we need to do this first. We need to throw the switch, and I need to see how they're going to be reporting that back to me. We've already talked to them about it. They will indicate it, but I need to do a trial run before I actually make that switch and make it go live. So that will be coming here in the next couple of weeks. And on that similar note is how quickly will the new percentile ranking go up? And it's as soon as I get the data file from Australia, we'll update that the searchable database in the percentile ranking. So it should hopefully be hopefully the day that you all receive your updated EBVs, if not shortly thereafter. Any other questions?
I have one on your new robustness project that you're going to do. Is that on just Katahdins or is it on other breeds? And if it does include other breeds, will you be able to compare which ones adapt better to certain situations?
Roxanne,
Like climate?
the project does involve a breed from each of the 4 breed groups that are evaluated in NSIP: Katahdin, Polypay, Suffolk, and Rambouillet. And there will be efforts for genotyping in all 4 of those breeds. Head-on-head comparisons are a challenge because those breeds are entirely independent of one another. They're not typically genetically connected. So it makes it hard to do those comparisons. I actually have another project underway with a postdoctoral student where maybe in the future we can use crossbred data to make those comparisons more direct. But indeed, we're going to be looking at the same set of traits in most of those breeds to get a sense of how much genetic variation we have to work with, to look at some characteristics that tell us something about their robustness, their general fitness, and their ability to be resilient to environmental challenges. Really, fluctuations in the climate is going to be the big one that we'll be addressing. Something in the Katahdin, which will be unique to Katahdin, just as a heads up for those who may be willing to participate, because we're going to be drawing very much on NSIP flocks once again as part of this effort. Huge contingent also from the 3 large USDA sheep centers, Dr. Burke's Katahdin flock, what happens at US Mark with Tom Murphy and Brad Frecking, and the newer Katahdin flock that's being established at the US Sheep Experiment Station with Brett Taylor. All of those folks are collaborators from the USDA in this research. One thing in the hair breeds, though, that we're going to start wanting to characterize are going to be the hair score. And so we'll be coming back to you about how we can deal with shedding as one of the attributes that we're going to want to start evaluating. So that will be unique to the Katahdin.
Thank you.
One of the other questions I see in the chat was when will the results of the last genotyping batch be sent out? If you're referring to the July 15 batch date, I sent those results out about 2 weeks ago. I did just get a call yesterday from someone who said they didn't receive them. So if you haven't received yours, maybe check your junk or your spam folder. And if they aren't in there, let me know and I'll look into it. But those went back, it was about 2 weeks ago.
Rusty, I have a quick question. This is Kathy. On the update that you just sent us for the EAPK newsletter, you said that the next submission date for genotyping was September 15th. Is that not happening anymore?
No, that date is happening. And actually, if you picked up on it, I said I'm in Montana right now. I won't be getting back to the office until the 16th. So you got a day grace period. So we are doing another batch here this week. As soon as I get back on Friday, those are going to be being sent off for analysis.
Okay, so the next one then would be in December that you were talking about earlier.
That's the plan for now, but as we mentioned, if there's enough interest, you can always schedule in another one if you need.
Got it. Okay, thank you.
Any other questions for the group, or Tom or Lynn, do you have anything else that you'd like to add?
I mean, I want to just say thanks again for I mean, we were up to 35 participants. We're still at 32. And so thanks for all of your interest, all the questions tonight. Thanks for Rusty. Thanks for Ron, for your presentation. I probably don't tell Tom thanks enough because I kind of roped him in on some of this stuff, and he's done a great job of trying to figure out how to especially make some of this TSU stuff work. And so he's been a great resource for the breed as well. And he does a great job on the board representing Katahdins. So, but no, thanks for everyone. I thought this was a great presentation. Thank you, Ron, very much.
And just to build
Yeah, I
on
appreciate everybody calling in. That's great. I won't say anything more. Lynn's thanked everybody so many times. I'll just just second all his thank yous to everybody, especially to Dr. Lewis for, it's been we worked, the ad hoc committee worked all fall and winter on things. And I know he was working nights because of the time difference with Australian stuff. So just a huge thank you to him for everything that's happened. So.
And none of this would have been possible without all of you all, the producers, collecting all this additional data, taking all the samples. So you all deserve a big pat on the back as well for making it all possible. Ron, I'll let you give any final thoughts for the evening.
No, just to say again, sincerely, thank you for being engaged in all of this. This is exciting. We have a really bright future with some of the upcoming research and efforts underway, and look forward to working with you and taking us to the next step. So thank you again. And if you have questions, please perhaps join us for the next round or send them through. And we just want to be sure you're comfortable with what's going to be happening come the 1st of October.
All right. Well, thank you, everyone. Thank you for tuning in. Appreciate your time this evening. Enjoy the rest of your evening. So I will, once this finishes buffering, I'll get the video loaded up so you can go back and ruminate on this a little bit more. So thanks, everyone, and we'll see you down the road.